Welcome back, everybody. Let's do a quick subscriber check. Let's see. YouTube. Whoa. YouTube. I guess I could go here. Okay. I guess I can go there. Let's see. Come on. My channel. 88. Only 12 away from 100. Let's go. Man, you guys are like, what do I have to do? Cartwheels up here? Come on now. Let's look alive. You don't think I can do a cartwheel?
No.
I'll do a cartwheel if you do a cartwheel.
I can't do a cartwheel, but sure.
It is. I would have done a cartwell. I honestly would have done a cartwell if you would
You
have
can
done it.
still attempt.
All right.
Wait, hold on.
All right. You have to do it.
All
right.
This is on video. This is on audio. Wow! I am impressed. Hayden Rudder just did a cartwell, everybody. Let's see who has the better cartwheel.
Oh,
That was a pretty good cartwheel.
Dude, he had the pointed toes and everything.
The pointed toes. All right, here we go. Hopefully that livened us up this week. All right, so section 3.1. Now we're going to be graphing and writing inequalities. Now, inequalities, when two things are not equal. When two things are not equal. Well, there's only a couple possibilities when two things are not equal. They obviously could be less than, could be greater than, could be less than or equal to, could be greater than or equal to, and they could be not equal to as well. So go ahead and write these in. I give you a little space here. This is saying that A is less than B. That's what that symbol means, less than. This is greater than, right? A is greater than B. I know this seems like very simple. Like, okay, we're actually writing down what these symbols mean? Yes, we are. Dude, David missed it. He missed it.
Dude, he did a cartwheel.
I did a cartwheel while you were gone.
Why do I not believe you?
Listen to the playback.
Yeah, it was actually really good.
Hayden did a cartwheel, so I did a cartwheel. He's like totally not believing it. Not that Hayden, not Hayden. Hayden Rudder, not Hayden.
He's like, hey, what do you want me to do? Cartwheels? And I said, all right, yeah, sure. He's like, all right, I'll do a cartwheel if you do it.
Okay, I believe you did one. I don't believe you did cartwheel.
Do it again. You're going to have to do it again.
No, I'm not going to do it again.
You're gonna have to.
No. This is obviously less than or equal to. Remember that if it's pointing to the left, like if the arrow is pointing to the left, then it's less than. What do I mean when I say pointing to the left? I mean when this is pointing to the left. This is pointing to the left. That's a less than. Okay. When it's pointing to the right, it's a greater than or equal to, depending on whether we have the line underneath. Those four should be very familiar to you. The one that may not be as familiar is the equal sign with the line through it. Because that's another possibility when I say two things are not equal. Right? It could be smaller, it could be bigger, or it could just be not equal to. We could not know. We could just say, okay, A is not equal to B. A is not equal to B. This will be a true test to see if like these people that are out like actually watched the video.
I watched.
You
I
did?
got 2 views on there.
Like to see if people actually watch the video. Like when John gets back tomorrow, we can be like, hey, did you listen to me do the cartwheel?
No, you.
John's not going to watch the video. Got it. Okay, well now I know. All right. So those are the 5 not equal to things. We could be less than, greater than, less than or equal to, greater than or equal to. And remember, that is the word or in the middle there. Less than or equal to. Greater than or equal to. And then not equal to. Okay? Now, when we graph these inequalities, obviously you have the space there to actually graph them. You've got a number line you're going to graph on that number line. All real numbers less than 5. Guys, am I going to put an open circle or a closed circle on 5? You guys remember what the rule is? Open circle on 5. Open circle on 5. Open circle on 5. How do I know that it's an open circle? Well, because it's just a less than. If it was less than or equal to, I would fill in that circle. Okay. Now, if I want all numbers less than 5, I would be going to the left of 5, right? Like, for example, like 4. Yeah, 4 is a solution because it's less than 5. 0 is a solution because it's less than 5. So I need that arrow to go over all of those possible solutions. So it's going to go to the left from 5 and forever and ever that way. Okay, all real numbers greater than -1, bigger than -1. Open or closed circle on -1? Open circle on, open circle on -1. Now this one is going to the right because I want things bigger than, greater than -1. So 0 is a solution. 5 is a solution. 10 is a solution. 1,000,000 is a solution. It's going to keep going on forever and ever in the right direction. Now, if I say all numbers less than or equal to 1/2, now that I have this less than or equal to, what is my dot? Is it open or closed? Closed. Closed dot, because it's got the or equal to. What do I mean when I say the closed dot? That means that it could be equal to 1/2, right? It could be equal to 1/2. I want all numbers up until 1/2, including 1/2. That's where I say or equal to. So if I want to include that number, I fill in that dot.
We don't have those measurements. Those are numbers.
Oh, you just estimated it around 1/2 there. Yeah, do what you need to do. Estimate it at 1/2. My graphs may look a little different from yours. That's okay. And then here is greater than or equal to 0. Obviously, closed dot, filled in circle at 0 pointing to the right because I want all numbers greater than or equal to 0. Greater than or equal to 0. You want to know the trick that I like to use? Everybody, eyes up here real quick. As long as the variables are on the left side, you can use this trick. If the variable's on the right, you can't use it. Or you'll have to manipulate it to make it be on the left. So notice how all my x's are on the left side. Look at the symbol. You see how the symbol is like the point of an arrow pointing to the left? Well, then obviously my arrow should point to the left as well. That rule applies to everything here. If I go greater than, okay, the little arrow is pointing to the right, so my arrow on my graph must also point to the right. You follow me there?
Mm-hmm.
So the direction of the symbol is the direction of the arrow, as long as the variable is on the left. If the variable's on the right, that does not hold. You have to put it on the left to do that. All right, so let's graph this inequality. We've got m is less than or equal to -3. Now, here's the deal. On your tests and quizzes, I will always give you a number line. Okay? On your tests and quizzes, I will always give you a number line to graph on. On your homeworks, here's what and obviously you have number lines on your guided notes, but on your homeworks, here's what I need to see. Well, let's put it on our number line first. Open or closed circle on -3? Closed. Fill it in on -3. And now, should my arrow be pointing to the right or to the left? To the left, right. Look at the symbol. The variable's on the left, so my arrow is going to point that way. So let's just do this. Look. There it is. Now, on your homework, do you have to make that full number line, going from -10 to +10 and all those little marks? No. Here's what I would like you to do on your homework. Make yourself a number line, and I need to see two things. I need to see 0 and then the number. I want to know if you have the relationship correct to 0. So obviously -3 should be on the left of 0, correct? Now we say, okay, is it an open or closed dot? Closed dot. And which way is it going? To the left. You can put your arrow above the line because obviously you don't have separate colors to do, right? So you can just kind of like stem it above the line and put it to the left. Does that make sense? That's all I need to see for your number lines on the homework. Okay, that's all I need to see. You don't need to make the whole full -10 to +10 number line, numbering everything. Okay, let's do a couple more. C is greater than 2.5. Now, am I given a 2.5 on my number line? No, that's okay. You can make a 2.5. Okay, you can make a 2.5. Like you can say, okay, here. Cool. Why did we do that? Get out of there. I can say, okay, here, that's around where a 2.5 would be, right? If you create the number on a number line, like if this is a quiz or test, I would love for you to say, that's at 2.5. Okay, label where you created that value. Is this going to be an open circle or closed circle? Open circle on 2.5. And which way is it going? Is it going to the right or to the left? To the right. To the right. To the right. What is that implying? Again, that's implying that every number bigger than 2.5 would be a solution. So like 8. Isn't the arrow pointing over 8? Is 8 a solution? Mm-hmm. Yes. If I plug 8 back in, is 8 greater than 2.5?
Yep.
Yes. This is implying that every number bigger than that value is a solution to that inequality. Keep graphing. Here's C. Obviously, we've got a little bit of work to do, right? So we have 5 times -1 plus 3, which 5 times -1 plus 3 is 2. So we've got T is less than 10. T is less than 10. So we solve there, we get T is less than 10. Is that an open circle or closed circle on 10?
Open.
Open circle on 10 going to the? Yes. Okay, good. So if you see an or equal to, if you see a line underneath, it's closed. If you don't see a line underneath, it's open. Less than or greater than is open. Less than or equal to, greater than or equal to, closed. Make sense? Okay, take a look here. Guys, what's 2 squared?
4.
What's 4 minus 4?
0.
So 0 is less than or greater than or equal to W. Watch out. This is the first time we've had the variable on the right side. I don't like to have answers with the variable on the right side. I'm going to move it to the other side. I'm going to say, okay, W needs to go over here, and now the 0 is on the other side. If I change the place of the variable, like if the variable was on the right, now I'm moving it to the left, you have to flip the symbol around. Okay? Think about it. I always remember this. My 6th grade teacher taught, oh, remember the alligator wants to eat the bigger number. So the alligator wants to eat the 0. Wants to eat the 0 down here as well. Those are teeth.
Yeah.
So W is less than or equal to 0. Is there an open or closed circle on 0? Closed. Going to the left or to the right? There we go. Okay, let's keep graphing. Or now we're given the graph, now we're given the graph and asked to write the inequality. So let's choose a variable. What do you guys want to choose?
X.
I'm just choose a variable. He's like, I'm just going to choose a number.
X.
J. Oh, I like J. We haven't used J. J. That's a J. It's not a J. J. Now, is it going to be J is less than or J is greater than? Because it goes to the left. The arrow going to the left, the symbol points to the left. Less than 2. Do I put a line underneath it?
No.
No, because it's an open circle. J is less than 2. X is less than 2. Z is less than 2. J is less than 2. Let's use Z here. Z. Tyler, what is it?
Oh, it's
Is it less than or greater than?
less than.
Am I going to the left or to the right? To the right. Remember, less
Right.
than, left. So it's not left.
Greater.
Greater. Greater than. Should I put the line underneath it?
Yes.
Yes, I should. And then it's at negative 0.5. Z is greater than or equal to negative 0.5. Okay, let's look at the last one there. Let's use X this time. Am I going to the left or to the right? Going to the left. So is this a less than or greater than? Less than. And it's at 2.5. Do I put the or equal to underneath it? It's an open circle. Okay, so now we know how to graph. And now given a graph, we know how to write it. When we talk about word problems with inequalities, it can get a little confusing. The wording can be confusing. If I ever say no more than, like I can have no more than 25 people in this room. Can I fit 26? No. That means it's less than or equal to. When I use the term no more than, that is less than or equal to. When I use the term at least, like I have to work at least an hour today. At least. Well, that means, can I work 59 minutes? No. I have to work more than, greater than, or equal to that value. Okay? These phrases, no more than and at least, always throw people off. Think about it logically. Think about, okay, can I fit 26 in them? Or can I work for 59 minutes? Think about it logically to kind of test out your answer. Okay? So for example here, a store's employees earn at least $8.50 per hour. Define a variable and write an inequality for the amount the employees may earn per hour, and then we're going to graph the solution. So if I say at least $8.50 per hour, what symbol am I going to use? Okay. Greater than. Greater than or equal to, right? Greater than or equal to, because could they possibly work could they possibly make $8.50? Yeah, it just has to be at least that amount. $8.50 still covers it. It just has to be at least that amount. So let's write, what do we want to say? X. I don't care. X. X is greater than or equal to 8.5. 8.50. I believe there's a number line there for you. Okay. So when we graph that, is that going to be a closed dot or open dot at 850? Closed. We're going to say here at 8.5, closed dot at 8.5. Is it going to the left or to the right? To the right. Remember, what is that arrow implying? That arrow is implying that all numbers to the right would be solution. Could they possibly make $10 an hour? Yeah, obviously. Sweet, that'd be nice. Okay, go over to the other sheet of paper, the other guided notes here. This is section 3.2, solving inequalities by adding and subtracting. So now, we're going to start solving these inequalities. Now that we know how to graph them, now that we know how to write them, what we're going to do now is solve these inequalities. Solving one-step inequalities is much like solving one-step equations. Guys, if I asked you this question, if I said 3 plus, I'll just do this. X plus 3 is equal to 10. How would you solve that equation? Subtract 3, obviously, right? We just took a whole test on solving equations. That's like the simplest equation that I could get, right? X plus 3 equals 10. We'll just subtract 3 from both sides, right? You would just subtract 3 here and subtract 3 here, and you get X is equal to 7, right? Guys, guess what? The exact same thing is true. Maybe I make this a less than or equal to. The exact same thing is true with the symbols. Right? You do the exact same thing. To solve any inequality, you need to isolate the variable using the properties that we've already used. Use an inverse operation to undo the operations in an inequality. If the inequality contains addition, use subtraction. If it contains subtraction, use addition. So what do I do, Tyler?
You would subtract 12 from 20 and 20.
Yeah. So we would subtract 12 from both sides. Again, stay organized, people. Stay organized. X is less than 8. Now, there's an extra step here. Because now not only do we have to solve, but look at the example directions. Solve the inequality and graph. Obviously, there's a graph for you, so you're going to want a graph. I've got my graph here. Now, again, let me show you what you would need to do on your homework. Obviously, there's a blank graph there for you. But if I wanted X is less than 8, this is the bare minimum I would need for your homework. I would need 0. I would need 8. I would need to see if it was an open or closed circle, and I need to see which direction it's pointing. That's the bare minimum for a graph that I would need on your homework. Does that make sense? On your tests and quizzes, I will always provide you with a graph. But on your homework, that's the least amount that I would need to see. Questions about that? Again, if there's a graph provided for you, you make it. See here, like this is, I don't know. Let's go by twos. 0, 2, 4, 6, 8. You can make the scale whatever you want. And then this is an open circle at 8 going to the left. Okay. Looks pretty similar to my graph up there. Okay, let's take a look at the next one there. What would we do to solve this equation? Or excuse me, this inequality? Add 5 to both sides. So we would say D is greater than -2. D is greater than -2. Okay, let me get my graph up here. Okay, if D is greater than -2, let's say this. Let's make 0 there. -1, -2. Is there an open or closed circle on -2? Open. Going to the right. Make sense? One more of those. Q minus 3.5 is less than 7.5. What solves that? What do I do there?
Add the 3.5 to the 7.
There we go. And I get Q is less than 11. Q is less than 11. All right. Come on. So in a graph that Q is less than 11, let's make this, let's go by, whatever. Here. This is what I would do. 0, 11, open circle on 11, going to the left. Questions about that? Let's take a look at the word problem there, the next word problem. Sammy has a gift card. She has already used $14, which the total was $30 on it, right? And solve and graph an inequality to show how much more she can spend. So when I want to write an inequality, again, that means I want to write an inequality, an algebraic inequality that I want to solve for. Don't start doing any operations yet, okay? So look at the last sentence to show how much more she can spend. So if X is the amount more she can spend, right? So that means X plus 14. Now, this is implying that she's got an inequality, right? So what would be my inequality? Would it be less than? Would it be greater than? What would I want here? Less than. Here's an easy way to figure it out. The total amount is 30, right? Can I spend $31?
No.
No, it's a gift card, right? I can't spend $31. Can I spend 29?
Yeah.
Can I spend 28?
Yeah.
Yeah, if I really wanted to, right? Because then I'd have some left over, right? I can spend amounts less than 30.
Would be equal to.
Can I spend 30?
Yes.
Yes. So that's why I include 30. Always test it out for yourself, Think about, can I go over? Can I go under? Can I equal that amount? So now I say I subtract the 14 from both sides. X is less than or equal to 16. Now, it's going to be even more important that you put your answer back into context. Okay, let's graph it. Let's graph it. I'm sorry, I see people graphing it already. Here's 0, here's 16, closed dot on 16 going to the left. Now, it's going to be even more important that you put your answer back into context, because my answer isn't just $16. My answer is not just $16. That's how much she's got left over. But I want to know how much more she can spend. My answer as an inequality is less than or equal to $16. That's what she had. That's what we have to say. She can spend less than, that's an S, less than or equal to $16. Sorry, $16. That's my answer. You're going to need to, when you state your answer, okay, when you state your answer, you have to reference the inequality. You cannot just say she can spend $16. No, she can. That's true. But can she spend 15? Yeah. Can she spend 14? Yeah. Because do your question.
Yeah, for one of these, can you say no more than?
Oh, I like that too. Yeah, she can spend no more than $16. Yeah, just make sure you put a phrase that references the inequality. Let's try another one there. A restaurant has room for 120 customers. On one night, there are 72 already dining. Right, and solve an inequality to show how many more people can enter the restaurant. Okay. So if I have X is equal to more people in the restaurant, well, my inequality therefore would be X plus 72, right? Those are I already have 72. I can add in X amount of people. Now, can I put 121 people in the restaurant? Can I put in 122? No. Can I put in 119? Yeah. So I can have less than or equal to 120. I can put 120 people in the restaurant. I subtract 72 over to the other side. So that's going to give me X is less than or equal to, 54. Is it 54? Sure. Okay. 120 minus 72. 48. 48. So when I go to graph that, here's 0, here's 48, closed dot on 48 going to the left. Put your answer back into context. Let's use no more than. I like that phrase. No more than 48 people. Questions about that? All right, let's take a look here. One last slide here. Write and solve an inequality to represent each statement. Solve the inequality, then graph. All right. The difference of a number and 3. Guys, how do we represent this piece? The difference of a number and 3. How do we represent that? The difference of a number and 3. Perfect.
Minus X.
You keep it the same order, X minus 3. But she's right, it would be subtraction. Now, is greater than. When we have is greater than, this is implying an inequality now. So we're going to say is greater than, and then we have negative 9 on the other side. And now we're going to have inequalities thrown in the mix as well with these words, transferring from word to math. I add the 3 to both sides, I get X is greater than negative 6. So when I graph it, here's negative 6 and here's 0. Open circle on negative 6 going to the right. and then our last one there. 7 is less than or equal to 4 more than a number. Now, do you remember when we had the term less than when referencing an operation? That was subtraction, right? Now, since we have inequalities, and it's saying less than or equal to, is less than or equal to, that's actually the symbol less than or equal to. Okay? There's a difference between less than a number or is less than. The word is implies that now we've got the inequality rather than just the operation. So 7 is less than or equal to 4 more than a number. Now, everybody pay attention to this one, please. Because when I solve this, I subtract 4 from both sides. This is not the difficult part. And I get 3 is less than or equal to x. Guys, that is a valid answer if you wanted to put that answer on a number line. But here's the catch. Which direction should the arrow point? Obviously, it's a closed circle at 3. But which direction should the arrow point? Should it point to the left or should it point to the right? It should point to the right. Even though the symbol is telling me to point to the left. The reason being is the variable is on the wrong side. To use that rule, the variable has to be on the left side. So now I can say, okay, closed dot at 3, going to the right. That was a fun day. That was a lot of math. Woo! That was great. Best video ever.